So we're just going to go over the vocab together that you guys just wrote down in your notebook. Go ahead and we're going to repeat all these out loud. Okay, so say these words after me just to make sure we can all speak the same language here. Okay, so repeat after me. Adjacent angles. Okay, that word adjacent. Two angles that lie in the same plane and have a common vertex and a common side. Okay, so they share a vertex. If I zoom in here, angle 1 and angle 2 share a vertex and a common side. Right? Pretty simple. Adjacent, the word, go ahead and write this down in your notes. Adjacent means next to. Two angles that are next to each other. Two angles that are next to each other. And they share a vertex and a side. Should have that definition down in your notes already. Okay? Okay, repeat after me. Say linear pair. Linear pair. Okay? Adjacent angles with, I don't particularly love the way it words that, non-common sides that are opposite rays. A linear pair, just two angles that form a straight line. Two angles that form a straight line. Non-common sides that are opposite rays literally is just a fancy way of talking about this straight line. So a linear pair forms a straight line, which means we know the measure of both of those. So angle 1 plus angle 2 equals what? What's the angle measure of a straight line? 180. So go ahead and write that down. And draw that picture for me next to your notes if you did not do that already for a linear pair. Angle 1 plus angle 2 is 180 degrees because they together fall on a straight line. Okay? Term number 3, vertical angles. Say that out loud. Vertical angles. Oh my gosh. Good morning, first period. We got to wake up a little bit. Say it out loud. Vertical angles. Thank you. Humor me this morning. Draw that picture if you did not already. We've got to have these picture examples in our notes. The definition's fine, but it kind of comes to life when we draw the picture. Two non-adjacent angles formed by two intersecting lines. I like to think of vertical angles. The word vertical starts with the letter V, and so, the two V's point at each other. So angle 3 and angle 4 are vertical. You see how those look like sideways V's kind of pointing at each other? And give me a different color here. Angle 1 and angle 2 are vertical. Again, two V's kind of pointing at each other. Really important part of vertical angles that the definition did not include. Anybody know something about vertical angles? Like the measure of angle 1 and 2 or the measure of angle 3 and 4? Go ahead, Miles. Ooh, not quite. Not quite. So a linear pair in this picture would be angle 2 and 3. But the vertical angles are 1 and 2. Go ahead, Luke. They're congruent. Great job. So go ahead and say that out loud. Say vertical angles are congruent. So angle 1 is congruent to angle 2. And angle 3 is congruent to angle 4. Anybody see this picture? Why is that a non-example? Well, I see two V's pointing at each other right here and here.
But it's not like two lines like intersecting each other. It's like a line and then the line is like that.
Yeah, two intersecting lines. So what we have here are 4 rays, or maybe 1 line and 2 rays. We've got line AC, but then it's ray ED and ray EB, right? So it's going to be 2 intersecting lines, meaning this guy right here kind of goes off a different direction. This line would have, what's going on? This line would have to extend straight for those to be vertical angles. You'll see that just visually. You got to be able to see the difference. Not really looking at the measure of the angles. Like I can't for sure tell on a picture that's not drawn to scale that those are not congruent, but I can see that this is not a straight line. So that's what I'm looking for on vertical angles. Okay. Oh, shoot. I just had to go down a little bit longer, and it tells me right there that they're congruent. Complementary angles. Go ahead and say that out loud. Complementary angles. Good. They equal, the sum of complementary angles equals 90 degrees. Okay. If you didn't draw that, go ahead and draw that. This picture right here, angle 1 and angle 2. What's really important on that picture in knowing that they're complementary angles? How? Yeah, Trevor said it. The only way we know they're complementary angles is because of the box, the square in the corner. We talked about that on Thursday last week when we drew right angles. Only way we know that is 90 degrees is because of that box. And then go ahead and draw the picture for supplementary angles as well. Say that out loud. Supplementary angles. Good. Supplementary angles. Two angles that have a sum of 180 degrees. So angle 3 plus angle 4 equals 180. Right here, angle 3 plus angle 4 equals 180 degrees. So draw those pictures next to your definition. So to put two terms together now, right, in a complete sentence, we would say the angles in a linear pair, there's one definition that we had, vocab term we had, are supplementary. Right, so we got two vocab terms working in unison with each other. The angles in a linear pair are supplementary because they fall on that straight line, which we already said the measure of that straight line is 180 degrees. Okay, moving right along. Last term for the day, perpendicular lines. Say that word out loud, perpendicular. Good, good, good. Reminds me of the part in Elf when he says Francisco. That's fun to say. Perpendicular, kind of a fun word to say. Two intersecting lines that form four right angles. Okay, just an interesting note. It says four right angles, but I only see one box. What's going on with that? I only see one right angle here. Y'all help me find the other three. Go ahead, Miles.
Because they're vertical angles and AB is equal to CD.
Oh my goodness. I see what you're saying. So these are vertical angles. So if this angle is 90 degrees, then this angle must be 90 degrees. But where do we get the other? That's only two. We need four. Go ahead, Luke.
They're both like in between, like both like the 90 degrees and 90 degrees, so they have to be 90 on both on the other sides.
Yeah, I know that, but explain a little bit more what you mean.
Because the 90 and 90 equals 180, then the other two have to be 90 and 90.
Why do these have to be 90 and 90?
Because
I don't know why they have to be.
the 90 and 90 is 180, and the line is 180. So
Oh, there we go. So what line are you looking at?
the CB.
Okay. So we're looking at line CB. And what's our vocab term for this?
Supplementary.
Well, yeah, so two angles that fall on top of a line are supplementary, right? They're a linear pair, right? So I'd say on line CB, I've got a linear pair. So if that's 90, that's got to be 90. And then I could say on line CB on the other side, that's a linear pair, or these are vertical angles, either way, right? That needs to be 90. Draw that picture with me if you're not doing that already. So two perpendicular lines form four 90-degree angles. And you're going to see this in your homework today, but you could also get a perpendicular segment, so go ahead and draw that example as well. Say we have a line here, and then just a ray or a segment, it doesn't really matter, going up off of it. Right, we're not forming 4 90-degree angles because there's nothing going on down here below the line. But if we're told that, I'll just label this E, this will be F, this will be A, this will be B. If we're told that line AB is perpendicular, that's the symbol for perpendicular. Go ahead and write that down if you didn't already in your vocab. That's the symbol for perpendicular to ray EF. Then I can still form these 2 90-degree angles here, right?
What's the symbol? It's just the upside down T.
The upside down T, this is the symbol for, you'll see perpendicular abbreviated, perpendicular abbreviated by perp. Good, 90 degrees there. So just to kind of give you guys another visual, it doesn't have to be lines intersecting with 4 90-degree angles. It can also just be a line intersected with a ray or segment, creating 2 90-degree angles. Okay. Questions on perpendicular lines before we jump into example problems?